Welcome back to Math Zen, everyone, and welcome to part 2 of the series on digit roots and how to use them. I can't wait to get into it, but before I do, if you haven't already subscribed, please do so by clicking the icon in the lower right-hand corner. It really helps the channel grow.
All right, so here on this page, you guys have a standard multiplication problem, 36 times 12. As you can see, we solve it the standard algorithm way and we get 432. When you solve that, most teachers will teach you to check this problem by doing what you see over there on the right, which is called long division. I don't know about you guys, but I am not a fan of long division. It really makes me uncomfortable. Matter of fact, here's how I feel about it.
No! God, please, no! 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 No!
Now, all joking aside, really, this is silly. Why would we do double the amount of work just to check one problem? Well, if you think it's silly, like I do, keep watching and we're going to figure out a better way to do this. Okay, so you can see here we have 39 times 24. It's been solved for you. Use the standard algorithm. We ended up getting 936 as our product here. Up until now, you've probably only learned that the only way to check your work here is to do long division. You would, hope that if you did 936 divided by one of your factors, it would equal the other factor, and if it did, you did your work right. That's just straight absurdity, if you ask me. Using digit roots is going to help us here, so let's check out how this works. If we take our product of 936 and we break that down to its digit root, you can see we did that. We did 9 plus 3 plus 6, which gave us 18. 18 wasn't a digit, so we broke it down further to a 9. 9 is a digit. So the digit root of our product was 9. So what we're going to do is we're going to take the digit root of our two factors, and since it's a multiplication problem, we are going to multiply them. If the product of our two digit roots has a digit root that matches our product, you did it right. So let's take a look at what we did here. We did 3 plus 9, which gave us 12. 12 was not a digit. And then we did 1 plus 2 to get 3, which is a digit. So our digit root for our first factor of 39 is 3. Then we do 2 plus 4, which is 6, which is a digit. So our digit root for 24 is 6. We take those two digit roots and we multiply them. 6 times 3 is 18. 18 is not a digit. 8 plus 1 is 9. 9 is our digit root. Those two digit roots equaling 9 proves that our product is correct. If you don't find that to be just straight fire, I'm not quite certain you have a pulse in your body. Now keep in mind, this is brand new to you and it was a lot of me talking. It's going to seem foreign, it's going to seem difficult, but I promise you, with practice at this, you can literally check these multiplication problems mentally in your head just by finding the digit roots of these numbers. So if you stick with me here on the next page, we're going to have an opportunity to do some practice. All right, here we go with your turn to practice. We are going to open up with the problem of 37 times 25. And we're going to go ahead and solve that. First step would be to do 5 times 7, which is going to give us 35. We're going to go ahead and carry the 3 and record the 5. Then we're going to do 5 times 3, which is 15, plus the 3 is 18. We're going to put our 0 to hold our place value. Then we're going to go 2 times 7 to get 14, carry the 1, write the 4, and then 2 times 3 to get 6, plus the 1 is 7. Add all this up, and we're going to get a product of 925. Now the digit root of 925, we're going to do 9 plus 2 plus 5, which is going to give us 16. And then 1 plus 6 is going to give us 7. So our digit root we're looking for is going to be a 7. So if we rewrite this over here, this is the part that eventually you can do in your head. I'm just writing it to show you what we're doing. We're going to do 3 plus 7, which is going to give us 10. 10 plus 0 is 1, so we get a digit root of 1 for our first factor. We're going to go ahead and do the same thing with the 2 and the 5, so 2 plus 5 is 7. The digit root there is 7. And since this is a multiplication problem, we're going to multiply 1 times 7 to get 7. Those two digit roots matching is the proof we need.
Hey, that's pretty good.
Okay, we've reached the point of the lesson where we are going to do some total independent practice. So if this is where you want to pause to try it on your own, I suggest you do that now. This problem 56 times 34 is going to be solved by starting off doing 4 times 6 equals 24. Carry the 2, write the 4. 4 times 5 is 20 plus 2 is 22. Put your 0 to hold your place. 3 times 6 is 18. Carry the 1, write the 8. 5 times 3 is 15 plus 1 is 16. Let's add these two partial products up. And we're going to get 4 there. We're going to get 10, carry the 1. We're going to get 9 there and 1 there. Adding these digits up, we're going to get 14. And that 14 is going to give us a digit root of 5. So if you got that part, congratulations, you're halfway there. Next up is 56 times 34. And we're not going to solve it now, we already did. We're just going to find the digit root of each factor. So we get 11, and that breaks down further to a 2. And then we're going to get 7 here, which is a digit, so we're going to leave that alone. And we're going to end up with 2 times 7, which equals 14. 14 is not a digit. 1 plus 4 is 5. 5 is the digit root we were looking for, so we can confidently say that we did this problem perfectly.
I really hope you enjoyed this mini-series on digit roots and how to use them. Remember, this is likely new to you and will take time, patience, and practice until you feel totally comfortable with it. Before you go, leave a comment letting me know if you liked this or not. So long, until next time, don't forget to keep searching for your Math Zen.